everyone, it's Mrs. Fitch here. I thought I'd put together a video little tutorial for you guys to kind of go over a quick overview and some examples in regards to the law of cosines. We worked on it in class, but I kind of wanted to put this video together just so that you could use it as another resource so you guys can view it and take some more notes on the topic. So when it comes to the law of cosines, we want to use the law of cosines when we want to find angles and sides of a triangle, and especially when our triangle isn't a right triangle is when we're going to use those laws of cosines and or the laws of sines. And we worked on the law of sines while we were in class, and so this is kind of like the next little step. When it comes to any triangle, we want to be able to label all of the angles and all of the sides. And there's a special relationship when it comes to these angles and sides. So on our triangle, we can technically label the three angles arbitrarily, whichever way you want to label them. So I'm going to say this is my angle A, this is angle B, and this is angle C. And I apologize for my penmanship. I have a new pen coming in the mail. It's just not here yet, so I hope it's legible. I hope. We'll see. So anywho, so we went through and we labeled our angles, and we always try to keep some consistency when it comes to mathematics and how we're labeling things. So we're labeling all of our angles with capital letters. And when it comes to our corresponding sides, we're always going to label those with lowercase letters. So we've learned that in mathematics, and especially in triangles and the constructions of triangles, when it comes to these triangles and these sides, our sides and our angles, have a special relationship with each other. So if we want to look at like this angle A here, I can take this side and this side, side AC and side AB, and I can technically keep those two lengths the exact same thing, but I could actually make my angle smaller, or I could actually make my angle bigger, and leaving those two side lengths the exact same measure. So like if this was my AB, and instead of AC being where it is, like technically I could kind of go there, and hopefully those are the same measurements. So those two sides stayed the same measurement, but what ended up changing when I changed this angle, it changed the length of this side, right? So we know that there's a direct relationship when it comes to our angles and their opposite side. I lost my B. There we go. So when it comes to labeling these, because we know that there's that relationship between the angle and its opposite side. So if this is my angle A, if I go directly across to that opposite side, I know that that has to be side A. If this is my angle B and I want to find side B, I know that that angle has a direct relationship to that opposite side. So I know that this side over here is going to be my angle, my side B. And the same thing with C. If this is angle C, where is side C going to be? That opposite side. So that's my C, right? And then when we were in class, we actually went through and we had this whole discussion about A squared equals B squared plus C squared minus 2BC cosine A. We went through and discussed how all of these kind of formulas came to be over here, which are all the different laws of cosines, depending on what side or what angle you're actually looking for. So I'm not going to get into where these formulas all came from. We did that part in class. We're just going to kind of go through some examples so we can get our math, our algebra part math, get all of our numbers where they need to be. Sound good? Alright, sounds good. So let's move on and look at an example. So on this example, we know that angle C is 101 degrees. We know that side A is 8 and side B is 19. So we need to figure out which one of those three laws of cosines are we actually going to use. And I'm going to sit there and because I know angle I know angle C, I'm going to look for side C. So I'm going to use the C squared formula. So I'm going to use C squared equals A squared plus B squared minus 2AB cosine of C. I apologize for my handwriting. I have a new pen that is supposed to be coming in the mail, so hopefully that'll help with my penmanship on my iPad. I hope it's legible for you. If not, use your imagination. We'll get through it, I promise. Alright, so now that I have my formula written, I'm just going to sit there and I'm going to fill in all of the values that I know, right? So do I know what C squared is, or do I know what C is, side C? No, I do not. So I'm going to leave that as C squared equals A squared. Well, if this is angle A, across from that is going to be side A. So we have 8 squared plus B squared. If this is my angle B, going to the opposite side, that's going to give me side B. So side B is going to be 19 squared minus 2 times A, which we said was 8, times B, which we said was 19, times the cosine of my angle, right? Capital letters are angles. So angle C is 101 degrees. So the cosine of 101 degrees, right? So technically, in my calculator, I could actually put all of this into my calculator and figure out what my C squared is. Or we can sit there and go through and figure out what each one of these is, right? The biggest thing about right now is when it comes to our calculator has two modes. It's got degree mode and it has radian mode. And in our trig pre-calc class, we've been going back and forth between those two depending on what we are looking for. So in this problem, everything that they are talking about revolves around degrees, right? I don't see any radians going on in this problem. Everything is in degrees. So I need to make sure that my calculator is in degree mode, or of course I'm going to get the wrong answer, right? So I'm going to grab my handy dandy trusty little calculator, and I'm going to put in 8 squared plus 19 squared. You should be doing this as well on your calculator to make sure we're all coming up with the same answers. Times cosine of 101. I come up with C squared is 483.0059. And granted, I'm just writing this on the screen just to kind of give you guys a visual, but in my calculator, when I go to the next step to find out what my C is and take the square root of both sides, I'm not going to put in the square root of what I have on the screen. I'm going to leave what's in my calculator, so that way I get a more accurate answer. Every time I do this, I'm truncating my answers and I'm getting an approximate, right? And eventually it's going to have an effect on our problems. So I just leave it the way that it is in my calculator and then take the square root of it. And then I'm going to get C equals, and technically when I take the square root, I'm going to get a positive and a negative number, right? Anytime you take square roots of a number, if I'm taking the square root of 483, I'm going to get a positive and a negative value. But I know that I just want to look for my positive value because I'm talking about an actual length, and I know I can't have a negative length, right? Even if I'm walking backwards, I'm not walking negative distance. I'm still walking a positive distance. So when I take the square root, I know that I'm going to get a positive number. And I'm just going to round it to the nearest degree, and I'm going to get 22 meters, right? So I know that my C is 22 meters. Oop, that's an M. Beautiful M. All right. So when they want us to solve the triangle, they want us to solve it for all of the angles and all of the sides. So I have all of my sides, but now I need to come up with my angles. And this is where we can use that law of sine that we learned, right? The law of sines was the sine of angle A over A equals the sine of B over B, right? Back to that relationship between those angles and those opposite sides, right? Sine C over side C. So I'm going to look at my problem, and I ultimately need to know one of these ratios in order to solve the problem. So I either need to know, for an example, like sine A and side A. So I need angle A and side A. Well, here's angle A and here's side A. I know side A, but I do not know angle A yet, right? So granted, that might be one that we're looking for, but to start with, I always find one where I know the angle and the side. So I know that relationship between my C's. So that's where I'm going to start. So I'm going to start with the sine of 101 over 22 equals, and then now I can pick either A or B. And just for simplicity, I'm going to stick with A. So I'm going to have sine A over, sine of A over side A, which is 8, right? And now we've worked on these problems previously, but we'll just run through it real quick. So ultimately, I have two ratios that are equal to each other. So ultimately, I know that if I multiply the numerator and denominator of the opposite ratio and the numerator and the denominator of the other, those are going to end up being the same. I think I said that a little backwards. I apologize, right? But ultimately, my numerator of 1 times my denominator of the other one is going to equal the numerator of 1 times the denominator of the other one, right? We kind of call this cross multiplying for simplistic reasons, right? So when I cross multiply, I get 8 times the sine of 101 equals 22 times the sine of A, right? Make sure we're not multiplying that 8 times that 101. That sine of 101 is technically one number, just like this sine of A is technically one number, right? I want to start working on getting my A by itself, so I'm going to divide both sides by 22, right? And I'm running out a little bit of room on this screen, so I'm going to kind of shorten this up a little bit. So ultimately, to get A all by itself, I'm going to take the inverse. I'm technically taking the sine inverse of both sides, and a function times its inverse is 1, so that's how we're ending up canceling that out. So I know that A equals the sine inverse of 8 times the sine of 101 over 22. And then I'm going to plug that into my calculator. And I'm going to round it, and I'm going to get 21 degrees, right? So then I know that my A is 21 degrees. Beautifully written. And then just off of triangle sum theorem, I know that if I add up all 3 angles in my triangle, it's going to be 180 degrees. So to figure out angle B, I'm just going to do 180 minus 21 minus my 101 is going to give me 58 degrees. So angle B is 58. I hope this example helps you guys. I had another example to kind of give you, but I know I'm kind of running a little short on time. So if you guys have any questions, make sure you reach out to me. We'll talk about using sines and cosines and Heron's theorem to figure out the area of triangles on our next little lesson. Have a wonderful day. I'll talk to you soon. Bye.